Welcome to this video. I did a video on variable in C programming language, and I promised after that video I'm going to do another one on data type in C. So now we are here. In today's video, we are looking at data types in C programming language. What are data types? And we are going to practically write programs on data type. So before we jump right into code blocks, by the way, this is code blocks. If you don't have code blocks on your system, I have a video on how you can download and install that. I'll link it in the description of this video. So now we have to look at the concept of data type. I prepared just a short note, a document on this. Okay, so I want us to look at the idea behind data type and how it works before we dive right to writing the code. So what are data types in C? Well, without any form of terminologies or jargons, in simple terms, data types are used to specify the type and size of data you store in a variable. We looked at variable the other day, right? And we said data types are used to specify. You specify two things: the type and the size of data that can be stored in a variable. So there are you have basic or primitive data types. So data types could either you start from the primitive data type. You can also have the derived data type. Then you can have data type qualifiers, right? So basically there are 4 data types, basic or primitive data types in C. That is what we are going to be looking at. Though I'm going to talk about other types of data types, but in the practical aspect, in the coding part, we are going to focus more on the primitive or the basic data type. So we have the first primitive or basic data type we are looking at is the Char, which stands for character. So what is that? It stores a single character. Take for instance, let's say letters of the alphabet A. So Char will only store just a single character. Then you have the int, which stands for integer, and int stores an integer value, and that will mean a whole number. It cannot store a fractional value. If you try to impute a fractional value or a number with a decimal point, it's going to return a whole number, because an integer an int data type stores an integer value, which is a whole number. 1, 2, 3, 4, you get that. Then we have the float data type. The float data type stores single precision floating point value. I'm going to explain that. Both float data type and double data type, they store floating point values or floating point numbers. What do we mean by floating point numbers? By floating point numbers, we mean numbers with fractional parts, right? Numbers that have decimal points. So why the int data type do not store floating numbers with fractional part or decimal point? That is an exclusive reserve of floats and double data type. So what's the difference between float and double then? For float, it stores a single precision floating point value. By that, it means that it stores numbers that have decimal points or fractional numbers that are small, right, with small value. And the accuracy for float data type, it's accurate to about 7 digits. Though some will say 8, 7, 8. It depends on the machine or computer you are working with, whether it's 32-bit or 64-bit. So that's just a little difference. Why for double, it stores double precision. First, by double precision, we mean that the size it stores is double, is 2 times that of the float. which is a single precision, which has single precision, and double can store value accurate to about 15 digit accuracy, right? Some will say 16. Like I said, it depends on your local machine, the bits in your machine. That is the primitive or basic data type we are looking at. So these are the four. I just talked about them. The char stands for character. Then we have the int, which stands for integer, float data type, as well as double. By chance, you might have heard about void, right? Void, you've heard about void data type. Yeah, there's void data type, but it's not among the primitive data type, right? So what is a void data type? It's the type that return no value, right? It's the data type that does not return any value. So hold that on one hand. That's what I may have a video later to expand on that, but practically I will show you during the coding section how that actually works. Then we have another one which I've not talked about, which is not again among the primitive data type. No, yeah, the string data type. I will hear somebody say, oh no, they told me in my class that string is not a data type. Of course, you are correct. C has no string data type, right? C has no string data type. Instead, you have an array of character variables, which is used to signify or to indicate the string data type. So string is not a data type in C. Rather, you have an array of characters. By array of characters, you have, if this is a single character, then this you have a single character here, another single character, another single character. S is a single character, I is a single character, N is a single character, G is a single character. So all of these single character, I can group them together to give me an array of characters. So you can see that this is now called an array of characters. So that is used to represent string. So I believe you understand that. So string is not a data type in its own in C. So let's look at the derived data type. By derived, of course, that means these ones are gotten from the primitive or the basic data type. That's the derived. They are derived from the primitive data type. So what are they? We have arrays, which stores a collection of elements. We have structures, which is simply a sort of collection of different types of data. We have unions. Of course, there will be, these are so broad, right? These are so broad. We will look at them individually in a different video. Array is wide, then you have structures. Then union. Union stores different types of data at the same memory location. Then you have, of course, the great pointers. Pointers, they store the address of another variable. So pointers will store the address of another variable. Then again, we will look at data type qualifiers. Data type qualifiers. That is what I have here now. What are these? Though I'll have again a separate video on that. But for data type qualifiers, they could either be short, long. Then you have another one which is the long. Short, long, and the signed, and lastly, I think I have that, right? Yeah, lastly, unsigned. So these are data type qualifiers. So they are used alongside with the primitive data type, right? So this could be, when we say short data type, long, and the rest of them, if you declare this as it means, if you declare short, which is a data type qualifier, it means you want to reserve less memory, right? Maybe the number you want to print is very small, so you don't want, but the computer don't really like the idea of reserving a large memory. Meanwhile, what you need is just a small memory. So rather than declare long or long and you are using a very small memory, you are wasting memory space. You are wasting the computer's memory space. So it's better you reserve exactly what you need, right? Exactly what you need. So if you declare short, it means that, oh, you are telling the computer you want to use a very small memory. And by implication, short will store 2 bytes of memory. And you should know that 1 byte is about 8 bits. And if you do that calculation, that will be 2 bytes will now be how many bits, guys? 2 multiplied by 8. And that will give us what? That will be equal to what? 2 times 8, that is 16 bits. So short stores 2 bytes of memory or 16 bits of memory. Then you have the long, and it means you want to maybe reserve much more larger space than short, and that stores 4 bytes of memory. And like I said, a byte, 1 byte equals to 8 bits. That will be 4 multiplied by 8. I believe you are following. Just have to do this, right, so that it becomes, at least you understand what we are talking about. That will be 8 bits. Okay, 8 bits. Then you have long. For long, it means you are reserving much more memory space, and that will be a whopping 8 bytes of memory size. 8 bytes of memory size. And again, if you do that calculation, that will be what? 1 byte is equals to 8 bits. So 8 times 8 is going to give you what, guys? That will give you 64 bits of memory. So that is that. So again, you have the signed and unsigned data type. What does this mean? What does this stand for? For signed, if we declare a signed data type, it means that we want to print only positive values, positive number. That is what that represents. And for unsigned, it means that, okay, let me. So for signed and unsigned, sorry, I beg your pardon, signed represents both positive, that was a mix of positive and negative number. And if I want to print or sign, prints or represent, let's say prints only positive number. So that's the difference. So that is that. So look through that, and again, we'll have a separate video to look at all of this concept. But in what we are going to be looking at proper in the programming session, we are going to pay attention to the primitive data types. So if you're ready to code, let's jump back at code blocks. Let's do what? Let's write some code. All right. In code blocks, we are going to be writing our code. So first, the data type we talked about, we are going to be illustrating them one after the other. So that is what we are going to be writing now. So the integer, the int data type, we are going to represent that here. So what I'm going to do, this is include standard input.h, which I'm going to explain what that stands for shortly. Then int, I'll declare an int variable, and This is main. This is the function name, and this is an empty function without parameters. Then I'll come down here. I'll open that curly braces and int I. Okay, let me just declare that. I declare a variable called I, an integer variable, and I pass a value. I assign a value, a number, a whole number, like I explained earlier. I pass a whole number to that. Then, after that, then I want to print out using a printf function to print this line. We are printing the value of that. This line will print a whole number. We print a whole number. Then I'll use a format specifier, which is D. Means I'm printing an integer number, a whole number. Then I'll print this I'll create a new line. Then after all of this, I will, what I declared here, I am going to print out the value of that. So comma I. So that is my program, and at the end of the day, I'll return 0. So even if I don't put this, this is we are doing this for this is the standard, right? To return 0. This shows that our program runs successfully. After our program runs successfully, returns 0. So this is just a simple program that prints an integer value, a whole number. Here we used include standard input output.h, which is a header file, because we want to include the printf function, right? Before you can use printf, you have to include this. There are so many header files, but we just included one because we are printing this. We are using printf function. So we declared this an integer, this a function name main. We called it main, and we declared an integer which we called I. Then we initialize, we assign the value 45 to I. Then at the end of the day, this line will print. We are printing this to the console, to the screen of our computer. Then integer value in a new, this is a new line. Then we return the value of I. So at the end of the day, return 0, which shows our program have run successfully. So I'll go ahead and save this. Then I'll build and run. So build and run. All right, so you can see this line will print a whole number 45. All right, so you see how that works. I didn't have to type 45 here. I needed to just put this I, this variable I declared here. Okay, so that is how an int variable work, int data type, right? So again, after that, I have this other program here. And here again, I'm including standard input output.h. You know the reason, like I said earlier, because I'm using the printf function. Anytime I use the printf function, I have to include standard input output.h. Here, this time, I want to declare what? You have a guess? Right? I want to declare a character variable, right? Character variable. Then that variable I give u. Then I assign a character to that variable, I assign a, just a single character. Then printf, this line will print the alphabet colon to show that. %C, this is a format specifier. Like I said earlier, format specifier what does that do? %C is going to tell the computer that I want to print a character, right? I want to print a character. That is what it does. And at the end of the day, then I want to output the variable which I declared here and return 0, which shows that my program have run successfully. So let's save this. Let's try and build that run. So you see, this line will print the alphabet A. All right. I believe you can see this clearly. This line will print the alphabet A. So that is, we have, demonstrated how the character data type works. How character data type works. Again, I have yet another program here. All right. I have another program here that, again, I don't have to explain this. Like I'm using a header file stdio.h because I want to use the printf function. So this is the main program, which shows that this is the program. Let's say the program entry point. This is the program entry point, and you want to know the exit. Let's say this is the program exit point, if you like. Exit point. So I just needed you to know that. So here I declared a data type float, right? The float data type. I declare float data type, and I used the variable. I used the variable f to represent that, and here I assign a value to my variable. I'm going to show you why I did this. Then at the end of the day, I want to print, this line will print single precision float value, and I use a format specifier, which is telling the computer I want to print a float, which is %f. At the end of the day, I returned my variable here, and I exit the program. Let's just say program exit point. So this is it. So let's try to run this. Let's try to run this, and let's see what we have. Save and build and run. So this is what we have, guys. This line will print single precision float value 3.899976. I want you to notice something, that it is not the entire value that we typed that was printed here. How many characters do we have here? 1, 2, 3, 4, 5, 6, 7. So earlier I said that float, is the precision. It will print value to 7. Is precise to 7-digit values, right? It depends on the number of bits of the computer, whether 32-bit or 64. So this just returns 7 digits, right? That's the value, the precision for float data type. All right. So meanwhile, the values we entered here: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you only printed how many? 7, right? 7. So if I want to make things right, I have to reduce this to what it can take. So build and run. Let's count 1, 2, 3, 4, 5, 6, 7. So I save again, build and run. All right. So it printed exactly what I have. Exactly what is there. That is what it printed this time. So again, we want to demonstrate how the double data type works, right? How double works. How double data type work. So here we declared the variable D to return a double data type, right? And we assign the value, this value to it. Remember, like I said earlier, both float and double, they are what? They store floating point numbers, which are numbers that have decimal points, numbers that have fractional points. They can store that, right? So they are specifically meant to store number with decimal point, fractional numbers. So printf, this line will print double precision value, percentage D. So this is the formal specifier for the double data type. If you want to print double, you have to use this. This is the formal specifier for double data type. Then at the end of the day, in a new line, then I want to output what? D. I want to output D. So at the end, return exit the program, return 0. So again, here, if you come here, you see that the double data type is accurate to 16 digits. Like, unlike float, we say float is accurate to how many? To 7 digits. 15 digits. 15. It's accurate to 15 digits. So let's save this, build and run. All right. So this line will print 35. Okay, that was shortened. So we now move to the another data type, which is void. In this program, I have I have a function that is going to return a void data type, right? Then this is, because I'm using printf, this is the header file stdio.h. So I want to print this message, print message to the output, to the console. So I'm using void data. Remember what we said about void data type, that is going to return the data type that returned no value. So that does not. So let's try to print this out. Let's see what happens. I save. So I print, build and run. So it's not printing. So let's try and log. Let's see the log. So let's see if there are some errors here. So if I open the log, the error message is warning, in function message return with a value, in function returning void. So what is the error message here is trying to say is that you are using a void data type and you want to print that it cannot print, because the void data type prints no value. So that is what the error message is, right? So what if I just want to print that message to the output, to the console? What do? I'm still going to print. I want to still print this to the output, so to the console. What do? Void cannot print this, because void does not return a value. So if I want to do this, if I want to print this, what I will need to do, I'll need to declare another function. So right here, after this, I'll have to declare another function. Let me close this. So I'll have to declare another function, int, with the name main. For another curly brace. So then I will have to call this function. In this second function, I'll have to call this function. So I'll come here, I'll call that function. To call that, I'll call using the function name, and I'll put that bracket. So I'll close that. Then I'll have to remove this. All right. So for me to be able to print this, I'll have to declare another function, and inside the second function, I'll call this first function using the name. That's function call. I'll call it with the name. So let me save this, and let's try and build and run. Let's see what happens. All right. So ladies and gentlemen, you see that we have successfully printed that message to the console. There is no error message. Why? Because here we have to introduce a second function, and we have to call the first function, because the first function could not print because we use what? We use this void data type that cannot print any value. So I believe you understand that. So again, lastly, let's summarize what we have learned so far. Let's summarize what we have learned in this program. So in this last program, what we have here is quite much. You could just look at that. We want to declare first character data type, give it the value, the variable a, represented by variable a. Then we declared variable I to return integer data type. We declared variable f to return float. We declare variable d to return double. So all of this represented the data type, the basic or primitive data type we looked at earlier. So we have some inputs. So let me explain what we have here. Some input, we have printf, and then we have scanf. All right, what does printf do? What does printf do? Sorry. Printf help you to print or display or print, let's just say display an output. Display, you can say display items to on the screen. On the screen, you can say to the console, but let's just say on the screen. That is printed to print a message out. Then we have another function here, which is called scanf. What does scanf do? Scanf is used to get an input from user, and you can say that is called what? A prompt. All right. Scanf help you is we require you to impute something, right? Which is called a prompt. So printf, enter a character. This will be printed to the console. Scanf, then this will require you to enter a character. And what we have here, we have a format specifier, which means that you must enter a character. If you enter something which is not a character, it's going to, the output will come out, it will not come out well, there will be an error. And then we have this and symbol here, which is called ampersand A. What does this do? Here, we are trying to get the memory location of this, right? Of A. So that is what that we do. So again, it's repeated here. Enter an integer, enter a character, enter a small value. So this we get the memory location. So you are printing, and these are format specifiers. So the output will be printf. So you are putting this character declaration. In the second one, you want to output an int, represented by I, then a float and a double. So shortly we will see how that works. So if I save, build and run, so again, enter a character. This is called a prompt, which I was talking about. Character A. Enter an integer, a whole number 67. Enter a small value 0.24. Enter a huge value 3779.44. A is a character, 67 is an integer, floating point single precision 0.24, double that and that. So that is just to summarize what we have learned here so far. You can look through this. That's a summary of what we have learned. So I believe that this was useful to you in understanding data types in C. All right. I'll come up with another video to explain the derived data type as well as the qualifiers, data type qualifiers, which are int, long, short, long, signed, and unsigned. All right. Thank you so much. I'll see you in the next video.